second table I asked you to try for homework was table 5.26. I've recreated it here. R has two strategies in this simple 2x2 strictly competitive game. R1 and R2. Column has two strategies, C1, C2. And here are the payoffs that are distributed depending upon the choice of strategies that either makes. Again, you can look at it and see there's no dominance. You can look at it and see that none of the pure strategies are in Nash equilibrium. So we need to find the mixed strategy that maximizes the expected utility of both players, from which neither would have any reason to move off because that move could be exploited. So again, we're going to use our formulas. And again, we're going to go again, give yourself these formulas. You don't need to memorize them for this course. Okay? And we're going to calculate the value of P given this payoff. Well, that's D minus 3 minus C minus 5 minus 3 minus 5 over A4 plus D plus minus 3 plus, minus B20 plus C5. This is going to equal minus 3 minus 5, that's minus 8 over 1, 4 plus minus 3 is 1, minus 25, that's 8 over minus 24, which equals 1/3. And now we calculate the value for Q, and we get the value D minus 3 minus B minus 20 over what we know is going to be the same value, minus 24, which is going to become minus 3 minus 20. That's minus 23 over minus 24, or 23 over 24, as column's optimal strategy for this game. So the optimal strategy for this game is the pair 1/3 R1, 2/3 R2, and 23 23rds C1, 1/24 C2. This will give the optimal solution to this particular game. Now notice C is almost playing a pure strategy, right? Almost playing a pure strategy to either lose 4 or to lose 5. But 1 in every 24 times, C is going to opt for playing C2 and taking that shot at gaining 3, but also the shot at losing 20. Not very often, but once in a while, whereas Row is going to play 1/3 of the time R1, but 2/3 of the time R2 because of that higher expected payoff based on the fact that 23 out of 24 times, Colin's going to play C1. We will come back and calculate the value of this game.